Hello, Divyangi.
Good evening, sir.
Good evening. You were absent in the last class.
Yes, sir.
Why? Okay, no
So I
problem.
had exam
Okay. Which exam?
chemistry.
Okay. And how was your exam?
So it was fine.
Okay. From organic or from inorganic or from physical syllabus? I'm talking about the syllabus of the exam. Okay, no problem. So in the last class, I have discussed this. I have started from here, na multiplication of the vectors. But in the last class, I have discussed the scalar product. Okay.
Yes, sir.
Yeah. So you were absent. So I'm just telling you again. So suppose this is one vector, A vector, and this is B vector, having an angle theta. Okay. So this is known as the scalar product or the dot product. And when you will open this, you will get magnitude of A, magnitude of B vector, and cos theta. So you will get AB cos theta, and magnitude of A you can write A, magnitude of B you can write B. So finally you will get the result as a scalar. Okay. So for example, work done is a scalar product of force and displacement. Like power is a scalar product of force and velocity. So suppose how this result is scalar. Okay, suppose here is one force of 6 Newton, here is another force of 4 Newton, and angle between is 30 degree. So dot product of F1 and F2 is given by magnitude of F1 and F2 cos theta, magnitude of F1, F2 cos 30. So you will put the value, you will get only the numerical value or the magnitude of the force. Second thing, I have discussed the properties of the dot product. Simple things are there in the dot product. So first property, uh, the dot product is commutative. Commutative means here if you will write A dot B and that A dot B is equal to B dot A means when you will change the order, the dot product will remain same of two vectors. When vectors are parallel, dot product is maximum. So how the dot product is maximum? Vector A and vector B are the parallel vectors. Okay. So for the parallel vector, angle between the vectors is theta. Okay. So now dot product of A and B will be A dot B, AB cos theta. So instead of this theta, you will put 0. And cos 0 is the 1. And 1 is the maximum value of cos. Okay. Maximum value of cos. So you will get A dot B is equal to AB and this AB is the maximum value. So here coordinate axis you have, along x axis you have I cap, along y axis you have, what is this I cap, Shibyangi? I cap.
Unit vector.
Yeah, unit vector along x axis. Okay, I cap, j cap and k cap. So why I am telling the unit vector? See, this I cap, if I am writing I dot I means angle between I and I, same vector will be 0 degree, na? So this I dot I means magnitude of this vector, magnitude of this vector means I and cos theta, this is equal to 1. Accordingly, j dot j is equal to 1. If two same vectors are there, dot product of the two same vector A dot A, that is given by A cos theta, but theta is 0 because the vector is same. So this will become A square. This thing. If vectors are perpendicular, dot product is 0. Two vectors are perpendicular. So dot product will be 0 because this is cos 90. Cos 90 is 0. So like you have this I vector and j vector. I vector and j vector are perpendicular. So angle between them is 90 degree. So I dot j is equal to 0 degree. I dot k is equal to 0 degree. Distributive property. Distributive property means if expression is written like this, a vector dot b plus c. So this can be written like this. This A will be distributed to B as well as C. A dot B plus A dot C. So there is one more form of dot product, that is dot product in Cartesian form. I have told you what is Cartesian form. When you write the vector in terms of the unit vectors, okay, that form is known as the Cartesian form. So this A vector is in the Cartesian form, A1 I cap j, A2 k cap, and this B vector is given as this. So when you will do A dot B, so what you will do, you will just multiply this with this, because this I cap dot I cap will become 1. We have already defined that. So this will become A1 B1, A2 B2, and A3 B3. Okay. So A dot B will be like this. For example, here is A vector, here is B vector. When you will do A dot B, so this will be, here is 1. This I can write this 1 I cap, 1 and 1 means 1. This 2 into 3, 6. This is minus 1 plus 4, minus 4. So this will become 3. So dot product, you should know what is dot product. I have done one question also, and this question you can do. Calculate the angle between the vector A vector and B vector. A vector is given as, B vector is this. So you will write A dot B, and A dot B is AB cos theta. Theta is the angle between A vector and B vector. So cos theta can be calculated from this equation. A dot B divided by AB. So we will calculate A dot B, and A means the magnitude of A, B means magnitude of B. We will put all the values and we will get finally minus 8y108, and this theta will be given by cos inverse minus 8y108. This is cos theta, and when you will calculate this theta, this will become cos inverse minus 8y108. Okay, like tan theta is equal to 1, so we can write theta is equal to tan inverse 1. So I have given this question to the other student. I think she is absent today. So we will solve this. One thing more I have told you in the last class. Position in the displacement vector. So position vector means simply, this is a point P. This point have the coordinate x and x comma y. This coordinate have the coordinate x comma y. Then the position vector of this point P can be written as xi plus yj. Simple, xi plus yj. Position vector. Suppose for example, this is the point Q, and we have to find the position vector of point Q. So you will write position vector xi plus yj. What is x? 2i plus 3j. Okay. If this is the case, 3 coordinates are given, then you can write the position vector of point Q, 2i plus 3j plus 4k. Position vector of point Q. Now displacement vector. Displacement vector means, suppose this is the one point P. This point P have the position vector r suffix p, and this point Q has the position vector rq. So displacement vector means you are moving from this point P to the point Q. So position vector of this PQ is given by RQ, position vector of Q. Displacement vector of PQ is given by position vector of Q minus position vector of P. Okay, minus position vector of P. For example, position vector of P is xi x1i y1j z1k, because x1 y1 z1 is the coordinate of this point P. x2 y2 z2 are the coordinate of this point Q. So position vector of P is x1 y1 z1, Q x2 y2 z2 k cap you can write. So position vector of PQ is given by x2 minus x1 I cap, because you will subtract this from this. Okay, RQ minus RP, you will write RQ minus RP. So you will write x2 minus x1 I cap, y2 minus y1 j cap plus z2 minus z1 k cap. And this, what is this RPQ? RPQ is the displacement vector from point P to point Q. Have I shared the notes on the group?
No, sir.
Okay. So now we will solve this question. This is very simple question. Very simple. Here a force is given. A force is given, and this is the Cartesian form of writing vectors. Force I cap plus 2j cap plus 3 cap 3k cap Newton is given. Acts on a body and it moves from, and one there is one doubt now for you. You have told me last that day. So that doubt I am telling now. Suppose this is your body. This is any body, you can say. This is any body. And on this body, suppose take the circular. So what is happening? Suppose one force is acting on this like this. This is 2 Newton. And another force on this body is like this. And this is 3 Newton, suppose. Okay. So what we will do now? What we will do? I can just write these vectors like this. Here is this one vector, and here is this another vector. Okay, and I can just replace this. So this vector will be your 2 Newton vector, and this will be your 3 Newton vector. What I have done the parallel shift of the vector. Parallel shift of the vector, because I have just shifted this vector here and this vector here. Okay, I have shifted this vector like this. Okay, and I have shifted this vector like this. Now got it? So finally you will get this. So this will
Yes,
be some
sir.
angle. Actually, now what happens here? We are studying the free vectors. Free vectors means we can shift the one vector parallel to another vector. Parallel to another vector. Like suppose I am saying here is one vector like this. This is one vector. This vector have the magnitude of 2 Newton and direction is this. And there is one another vector. Suppose this vector name is A1 vector. And there is another vector like parallel to this vector. Okay, parallel to this vector. This is A2 vector. And this vector also have the magnitude of 2 Newton. So we will take these two vectors. What is the condition of equality of two vectors? Direction same, magnitude same. So here direction is also same, magnitude is also same. So both the vectors we will take here same vector. A1 vector is equal to A2 vector. A1 vector is equal to A2 vector. Means if you have a vector, suppose you have this vector, na? So you can parallelly shift this vector and the magnitude and the direction of the vector will not change in case of the free vectors only. So that is why, okay, earlier this was the condition. This was the condition. I think now it's clear.
Yes, sir.
So we are studying the free vectors, means we can just suppose we have this vector, we can parallelly shift this vector to this point. Parallelly shift, parallelly only. Okay. So now this question, a force this act on a body and it moves, means the body moves from point A to the point B. Very simple question. Suppose this is some body and force is acting on this body and this body is moved from one point to another. This is point A to the point B the body has moved. The coordinate of point A is given as 2, 3, 1. Coordinate of point B is 3, 1, 1. 3, 1, 1. 3, 1, 1. So initially the body is here. When you have applied the force from here to here, the force is applied on this body. This is the body. This is a particle, or you can say body. I means the initial position and F means the final position. Force is applied on this body. This force is given like this. And body moves. They are asking what is the position vector of A and position vector of B. Can you find the position vector of A? Very simple question. Position vector of A is given by xi cap plus y of j cap plus z of k cap. What is x? 2i cap
Yes, sir.
plus 3j cap plus k cap only. So this is the position vector of A vector. RA is the R represents the position vector. Okay, in NCERT the position vector is represented by R. That is why I am representing the position vector with R. Otherwise you can represent it with P also. So R suffix V. This is a small r. Okay, this is a small r. So position vector for point B is equal to. Just tell me what will be the value of position vector for point B directly.
3i cap plus j cap plus k cap.
Good. 3i cap plus j cap plus k cap. Now this body is moving from point A to the point B. Now we have to calculate the position displacement vector. Displacement vector from A to B. Simply displacement vector. Displacement vector from A to B means R suffix B means position vector of B minus position vector of A. So position vector of B is 3i plus j plus k. 3i plus j plus k cap, j cap plus k cap minus RA 2i cap plus 3 j cap plus k cap. So this will become 3i cap minus 2i cap means I cap. This is j cap and minus 3j cap means 2j cap minus. This is k cap and minus k cap. Okay, cancel out. K cap minus k cap will be cancelled out. So this is your displacement vector. This is your displacement vector. Now answer 3. Work done. Work done in moving the body from this A point to the B point. The work done formula I have already written. Work done is the dot product of force and the displacement vector. Displacement vector. So here the displacement vector is given as RAB. Okay. Force is also given, so we will get the work done. And actually here is this, there will be no arrow because work is a scalar quantity. Because dot product will give you the scalar. So work done will be the force dot displacement force is I2 means I cap plus 2j cap plus 3k cap. I cap plus 2j cap plus 3k cap dot displacement vector means RAB, that is I cap minus 2j cap. I cap minus 2 of j cap. Now dot product of this will become, this is I cap and I cap, I cap and I cap. Here you will get 1 plus 2j cap and minus 2j cap will be minus 4 because 2 and minus 2 will be minus 4. So you will get minus 3 joule of work. Unit of work is joule. In work power energy, we will study the work in detail.
Sir, sir, there was plus 3k cap also.
Okay. Why I have not written that now? Because see here, I have told you you have just a minute. This is now, we have to do the dot product of this and this vector. So I can write now this vector as plus 0k cap. Okay. So when you will multiply this with this, it will become 1. You will multiply 2j cap with minus 2j cap, it will become minus 2. When you will multiply 3k cap with 0k cap, it will become 0. Oh sorry, it will become minus 4 na, and it will become 0. So that is why this is minus 3. Got it now?
Yes,
We
sir.
just, okay, just giving one question, just try to solve it by yourself. A vector is given as k cap, V vector is given as I cap minus 3 of j cap, and you have to calculate the A dot V. Just try this, take your time, step by step do. Okay, just time telling. Okay, so you have to calculate this now. So first take the A vector. So for this A vector, you can write, now focus on the screen. A vector, you can write 0 of I cap plus, because here is only k cap, and you can write this as 0 of j cap. You can write this plus 1 of k cap. Now for B vector, you can write, you have I cap, so you will write here I cap. Now see for the j cap. J cap is also there, so you will write minus 3 of j cap. Okay, k cap you do not have in B, so you will write 0 k cap. Now multiply, now take the dot product A dot B. So for the dot product, what we take? You can write this as 1 I cap. So what we multiply? We multiply just the coefficient of I cap with I cap, j cap with j cap, k cap with k cap. Coefficient of I cap is 0 and 1. So means 0, 0 into 1. Here 0 into minus 3. Here 1 into 0. So that is why this will become 0. Is it or not? Got it?
Yes, sir.
The dot product is very simple as compared to the cross product. Okay, Definitely today I will try to share the notes so that you. Okay, just note down this. This question is very important. This dot product and this cross product, the whole chapter, the vector is very, very important. Very important. Throughout the physics, the vector will be used. Throughout the physics till 12th. Again and again, vectors will be used. Without the study of the vectors, the physics we cannot elaborate, or we cannot explain, or we cannot understand the physics.
Done, sir.
Okay, scrolling down. Do you have OneNote in your laptop? OneNote, Microsoft OneNote.
No, sir.
Okay, so you have to download that. On OneNote, you will get these notes. OneNote, WONE1 NOTE OneNote. This is of Microsoft. Like we have Excel, like we have Microsoft Word. Similarly, we have my OneNote.
Written.
Okay, okay. Copy this also, this question also.
Yes.
Okay, okay. So download OneNote in your laptop, and maybe today I will share the notes, and you have just left the classes, so you can revise the notes. Okay, you can go through that notes, because in physics everything is linked with one another in this chapter or in physics. Hmm. Component of one vector along another. Component already discussed, but again I am telling component. Suppose this is your vector A vector, and this is your x-axis, and along the x-axis what is I cap? This I cap is very important. I cap is the unit vector along x-axis, and I cap is used for the direction. Suppose 5 I cap is written. 5 is the magnitude. I don't know what is 5. 5 can be the velocity. 5 I cap can be the force. 5 I cap can be the displacement. But 5 I cap means along x-axis, positive x-axis. Okay. So now I am taking the component of this A vector, component of this vector along this x-axis. We have already discussed this topic. Component of this A vector along x-axis will be A cos theta, and no need to take the sign component. So component of this A vector along x-axis is A cos theta. So what you will say, A cos theta, component of A along x-axis. We already knew this. Now see, suppose I am taking the dot product of this A vector and this I cap vector. This is A vector and this is I cap, and I cap is in x-axis. So now how I will open this? This will become magnitude of A vector and magnitude of this I vector. And what is the angle between the I vector and A vector, Divyangi? I vector and A vector angle.
Theta.
Theta, good. So this will become cos theta, because A dot A vector and B vector is equal to AB cos theta. Suppose I have written like this, PQ, P vector dot Q vector. So this will become PQ cos theta. So in the same way, A dot I is A vector, I vector cos theta. And I vector is the unit vector. So the magnitude of this I vector is 1. So now open this. This will become A cos theta. Because I know that this A vector can be written as A also. So see, this A dot I cap is equal to A cos theta. A dot I cap is equal to A cos theta. And what is A cos theta here? A cos theta is the component of A vector along x-axis. So you can say the dot product of a vector, dot product with the dot product of the vector, we can calculate the component of one vector over another vector. Okay, now I am taking some different example. For example, this already taken the. So this is your A vector. This is your A vector, this is your B vector, and angle between A vector and B vector is theta. Now I don't know the means along which axis or along which direction the A vector is. Okay. This A vector is neither along x-axis nor along the y-axis. Same is the case for the B vector. One thing you should know, this B cap. What is B cap? B cap is the unit vector of B vector. Unit vector means having the magnitude 1. B cap is the unit vector of B. I have already told you that unit vector represents the direction of the vector. Ij cap are the unit vector, those I cap, j cap and k cap represents the direction along x axis, y axis and z axis, but this v vector is representing the direction of the v vector in the direction of the v vector. Okay, so unit vector of v vector in the direction of the v vector. So this is this v vector representing the direction of this v vector. Okay, so I have written also here gives the direction of v vector. So if I want to find the component of a vector on v vector, component of so component of a vector. Now I am not calculating the component of a vector along x axis. Now I am just calculating the component of a vector along this vector. Okay, a vector along b vector. What we will do, first we will write this a vector dot of the unit vector in the direction of the b vector. Okay, and we will get mod a b cap cos theta. And what is b cap? B cap is a unit vector, so magnitude is 1. So again I will get a cos theta. So a cos theta, what is a cos theta? A cos theta will be the component of a along b. Component of a along b. This a cos theta is the magnitude of component of a along b. So now if you want to find the vector, if you want to convert this a cos theta into the vector, you will multiply this a cos theta with the unit vector in the direction of a cos theta. Okay, so vector component, you can write vector component of a vector along v vector. Simply you will write a cos theta into b cap dot a cos theta into b cap. V cap is the direction of a cos theta and a cos theta is the magnitude. So this is the vector now. So finally you can conclude that component of v vector, if someone is saying calculate the component of v vector along a vector, and theta is the angle between a vector and v vector. So how you will calculate the component of v vector along a vector? V cos theta will be v cos theta and unit vector of a vector. So this is your suppose a vector and this is suppose your v vector. This is the angle theta and you want to calculate the component of this v vector. Component means some part of this v vector along this a vector. That will be v cos theta and here will be one unit vector. So this will become v cos theta. This is not dot. So simply a vector, unit vector of a. And how we will calculate the unit vector of a vector or v vector? First we will write a vector divided by magnitude of a vector. I have already told you. For unit vector of v vector, we will write here b vector divided by magnitude of v vector. Just note down this. We'll solve then one question on it.
Done, sir.
Okay.
Done.
Okay.
Written.
Okay. On this, we will do one question now. Hmm. Okay. So, question is, A vector is given I cap plus 2 j cap minus of k cap, and B vector is given I cap plus j cap plus 2 k cap. They are saying calculate number one component of A vector along V vector. Second part, component of V vector along A vector. We have to calculate. So this is related with the previous topic we have just done. So we want to calculate the component of A vector along V vector. Okay. So component of A vector along V vector is given by A cos theta dot B cap or you can write this like this. Component of suppose A dash is the component of A vector along V vector, and this can be given by A vector dot B cap and multiplied by B cap. Here also I think I have written.
Yes, sir.
Just a minute. Same thing I have written. Now means you can write in this form also a cos theta into b cap. Okay. A dot b, when you will open this a dot b, this will become ab cos theta, and this is b cap vector. Okay. So this is the thing. So what is a cap? A dash cap is the component of a vector along b vector. Remember this formula. Okay, this formula you should remember. And when I will open this formula, this will become a magnitude of a and magnitude of b cap, and cos theta and b cap is also there. So finally I will get this na a cos theta b cap. Okay. So I have written in this form also. So just add this formula also there. Okay. Finally you will get this when you will open this. You can use this formula. Simple. Now a vector we have unit vector of v vector. How we will calculate? This will be v vector divided by v magnitude of v vector. What is v vector? I plus j plus 2k plus j plus 2k. And how we will calculate the magnitude of p vector? Coefficient of I square plus coefficient of j square plus coefficient of k square and under root. Means 1 square plus 1 square plus 2 square. So this will become I cap plus j cap plus 2k cap, and here you will have root 6. Is it or not? Got it?
Yes, sir.
Now what we will do? We will multiply a vector, not multiply. We will take the dot product of a vector and this vector. Okay. A vector, we want to find this a dash vector. No? So a vector dot this vector, and here is the unit vector of b vector. So a vector dot b vector. A vector is I plus 2j minus k. Dot of b cap. B cap is this I vector j vector plus 2k vector, and this is root 6. And here there is one more vector, that is b cap vector again. This is a dot b na. This is a vector dot b cap vector. Take this in the bracket. And here is again you will write this b cap, this I plus j plus 2k. Divided by root 6. Now take the dot product. So this 6 and 6 will be root 6 and root 6 will be multiplied, and this will become 1 by 6. Now multiply this vector. Take the dot product of this vector and this vector. This will become 1. This will become 2. This will become minus 2. And here is one vector. that is I plus j plus 2k. Finally, you will get the answer. This 2 and minus 2 will be cancelled out. So your final answer will be I cap plus j cap plus 2 times of k cap divided by 6. Or you can write this in this form also. I cap by 6 plus j cap by 6 plus k cap by 3. So this is your second part. You should try by yourself. Same concept will be applied in the second part. So in the second part, they are asking component of B vector on A vector. Component of B vector on A vector. So for the second part, component of B vector. So you will write, suppose B dash vector is your component of B vector along A vector. So you will write B vector dot of unit vector of A vector and unit vector of A vector. Okay. Here A dot unit vector of B vector and unit vector of B vector for component of A vector along B vector. And for this, you will write this. Can you do this question by yourself? You will put this vector, and this vector, and how you will calculate the unit vector of A vector? This by this. Just note it down. Divyangi, in your school, is relative velocity covered by the teacher? Relative velocity. Hello, Joylin.
Yes, sir.
You have joined at
So
just
5.
now.
No, sir. No, sir.
No, I have not seen that. I think you was absent. So getting now?
Yes, sir. Yes, sir.
Okay, just both of you note down.
So it was told that it will not be asked in the exam.
Teacher told na, because remove that portion is removed from your syllabus. Well, see the syllabus. I'm just giving you just a minute. Stop writing. The relative velocity is very important topic. Why they remove that? See this. Motion in a plane, all the things you have, but this is a deleted topic. Getting my screen? Okay.
Yes, sir.
The deleted topic. Here in this chapter, first chapter though is gone, but in the second chapter, this length, mass, time measurement, and this error analysis is removed. But you have dimension analysis and significant figures. Okay, so I will just give you the brief idea when we will reach there. Means after the projectile motion, relative velocity. We will not go in detail. Yes, because removed from your syllabus. That's why. But relative velocity is very important concept. Okay, just note down this. Definitely today or tomorrow I will share the notes. And Joylin, do you have OneNote in your laptop? OneNote.
Yes, sir. Yes, sir.
Okay, okay. Microsoft OneNote. Okay. So I will share the file on the group. So that file will be opened only on the OneNote. Okay.
Okay, sir.
So yeah, you should have OneNote for that.
Written.
Okay. Joylin completed.
Yes, sir.
Okay. Just write down this. So in the next class, we will discuss the cross product, and that cross product is the last topic of this vector. And after the vector, we will start the some basics of. I will tell you the half hour for the half hour. I will tell you some basic maths that will be used. After that, we will start the projectile motion because basic maths you should know. In calculus, that is differentiation, integration, you should know because differentiation is new for you, integration is new. You know the algebra from the 10th class, but you do not know what is the differentiation, what is the integration, where the algebra fails, where algebra fails. Okay. Where the algebra fails, we use the differentiation and the integration. So there was a scientist Newton who discovered the calculus for explaining the laws of gravity and all that. He used that. Actually, he invented the calculus. At that time, the algebra was not sufficient to explain.
Done, sir.
Okay, both of you completed.
Yes, sir.
So, can I take your 10 minutes more? If you are ready, if you guys are ready, means if you want to go somewhere else, then tell me. If you have some work and all that. If you are free, then I can take the time.
Okay, sir.
Mm,
Yes, sir.
okay, fine. No problem. So, after this, we have this topic, geometrical meaning of dot product, but I have covered this topic here. Means geometrical meaning means the component. Now, cross product. What is a cross? Cross product is very simple. But cross product is simple, but direction is not simple in the dot product. In the cross product. In the cross product, you have to see direction also. Cross product is written like this. A vector cross, this is sign of cross, B vector. And this cross product is written as magnitude of A vector, magnitude of B vector, and sine theta. Sine theta and n cap. Now what is n cap? N cap is a unit vector. N cap is a unit vector perpendicular to A cross B. Not A cross B, perpendicular to A vector and B vector. Perpendicular to A vector and V vector. And this cross product is very, very important. So cross product is this, two vectors have the angle theta. Two vectors have the angle theta. and this is the cross product A cross B, A vector B vector and sine theta. And what is A vector and B vector? Magnitude of A vector is A and magnitude of B vector is B. So simply you can write this in this form also, AB sine theta and n cap. Okay. And n cap is also representing the direction of A cross B. A vector cross B vector. Now direction of A cross B, because this A cross B, the result will be vector this time. The result will be vector this time. Like in the dot product, you have a result scalar, but in the cross product, the result will be vector. We will calculate the cross product, and there we will see result will be vector. And how you will calculate the direction? Because result will be vector, so for the vector we will calculate the direction also. So for the direction of A cross B, you have calculated this A cross B, na? This is A cross B. So there will be some direction of this A cross B, because this is a vector. Earlier we have the scalar, so were not calculating the direction. Now we will calculate the direction. Direction of A cross B is perpendicular to both A vector and B vector, and is given by right hand thumb rule. Right hand thumb rule. Okay. So you will get this A cross B. This A cross B will be perpendicular to A vector and perpendicular to B vector. Means suppose this is a plane. This is some plane. Okay. This is some plane. And there is one vector like this. Okay. And there is, just a minute. Two vectors are there. Suppose this is your A vector and this is your B vector, like this. These two vectors are on this plane. These two vectors are on this plane and making an angle theta. So what will be the direction of the A cross B? Direction of A cross B will be perpendicular to this vector and this vector. Okay, two vectors are there. Direction of A cross B, when you will take this, suppose this is a A vector, this is a B vector, you will take A cross B. For the direction of A cross B will be perpendicular to the plane in which two vectors are there. And always remember, two vectors will always be in the same plane. Two vectors will always be in a plane. Okay, two vectors will always be in plane. So direction of A cross B will be perpendicular to the plane containing two vectors. So this will be the direction. So this vector will be perpendicular to this vector. This vector is perpendicular to this vector also. Now right hand rule. This thing is clear that A cross B is perpendicular to A vector and B vector. How? I have shown you. Now direction of A cross B. So first what you have to do, you have to place your finger along the direction of one vector. place your fingers, just you can do by it yourself. You can place your fingers, this fingers of your right hand, place your finger along the direction of a vector and curl your finger towards the another vector like this. So your thumb will give you the direction of the a cross b. So my thumb is coming towards my face, means coming towards me, or you can this something is coming from out of the screen, something coming from out of the screen. So the direction will be outwards. This direction, something is coming towards me means the outward direction, and something is going from me means the inward direction. For the observer, I am the observer, and something is coming towards me. So I will say this direction will be the outward direction. If something is going away from me, I am the observer. Something is going away from me. So I will say the direction will be inward direction. You can take the example of your screen of your laptop. This on your laptop or mobile phone, whatever you have, you are watching this A vector and B vector. These A vectors and B vectors are in the plane of the screen. So I have told you the A cross B will be perpendicular to the plane of your screen. Okay, perpendicular to the plane of your screen. Suppose this is your screen, on this and the A cross B will be perpendicular like this, or A cross B will be perpendicular like this also, from here also. Okay, from the back side also. Okay, so A cross B will be perpendicular to A vector and perpendicular to V vector. And when you will apply the right hand rule, then you will get the proper direction of the uh, A cross B. So point your finger along the direction of one vector means A vector. If you are just calculating A cross B, then first point your four fingers along the direction of A vector and curl your finger towards the B vector like this. So your thumb will give you the direction of A cross B. Right hand thumb rule. Right hand and thumb. So according to the right hand thumb rule, place your fingers along a vector and curl it towards V vector. Thumb will give you the direction of A vector cross B vector. You will understand these concepts uh, in the rotational motion. In the rotational motion, you have n number of things. You will calculate their cross product. Okay, so just note it down. This cross product, in the cross product direction, finding the direction may be difficult for you or may be confusing for you. Okay, in the next class we will discuss now. You will have some quantities like angular momentum, like torque, like angular velocity. Those quantities are the rotational quantities. So there is a requirement of the cross product. Okay, you will study the angular momentum in the chapter rotational motion. In the circular motion, you will have the angular velocity, and torque will be in the rotational motion again.
Sir, rotational motion was started in our class.
Okay. Before the rotational motion, the chapters like the kinematics and Newton's laws of motion, work, power, energy should be clear. Otherwise, rotational motion you will not get. All the concept of the linear motion will be applied to the rotational motion. Completed?
Yes, sir.
Yes, sir.
Okay. Just write down this and we will meet in the next class. So for the rotational motion, your base should be clear. Because now it is easy to just analyze the motion when the body is moving like this. But that time the body is rotation in the rotation like this. So that time the analysis is difficult for that motion. And for that you should know the proper concept of vector and proper concepts of Newton laws and what is work, what is power, what is energy. Work and energy at least you should know.